Centripetal force. We've seen that an object moving in uniform circular motion is moving in a circle at a constant speed, and it's undergoing a centripetal acceleration, which is directed toward the center of the circle. What does Newton's second law tell us must be the cause of this centripetal acceleration? A net force. We call this the centripetal force. Centripetal force is a vector, so it has a magnitude and a direction. The magnitude of the centripetal force is the mass of the object in question multiplied by the centripetal acceleration. We found previously that the magnitude of the centripetal acceleration is the speed of the object squared divided by the distance between the object and the center of the circle of motion. So the magnitude of the centripetal force is equal to m times v squared over r. The direction of the centripetal force is the same direction as the centripetal acceleration, toward the center of the circle. A very important thing to keep in mind is that the centripetal force is not a new type of force, like the gravitational force or the normal force. It's just the net sum of the force vectors that are in the same direction as the centripetal acceleration, and thereby causing the centripetal acceleration in uniform circular motion. There could be gravitational, tension, frictional, and normal forces acting on an object in the same direction as the object's centripetal acceleration, and these all can contribute to the centripetal force. Let's look at a simple example where a tension force makes up the centripetal force. I fly my model airplane in a horizontal circle around me, guiding it with a rope. The weight of the airplane is balanced by the lift from its wings. The rope is 15 meters long. The airplane moves at a speed of 20 meters per second and has a mass of 1 kilogram. What's the tension in the rope? So let's first draw our picture, me flying my airplane in a circle. What does the problem tell us? First, it tells us that the airplane is moving in a circle at a constant speed. That tells us that it's moving in uniform circular motion. This means that there is a centripetal acceleration and a centripetal force directed toward the center of the circle. We're given a mass for the airplane of 1 kilogram. The length of the rope is 15 meters. And the airplane is moving with a speed of 20 meters per second. What are we looking for? The magnitude of the tension in the rope. Looking at our picture, which way is the tension in the rope directed? It's directed toward the center of the circle. This is the only force pulling the airplane toward the center of the circle, so the tension force makes up the centripetal force in this case. What is the equation for the magnitude of the centripetal force? M times v squared over r. So in this case, the tension is equal to this as well. So now we just plug in our known values for m, v, and r, and using our calculator, we can now solve this, getting a value of 27 newtons for the magnitude of the tension in the rope. So remember, when looking at the centripetal force on an object, make sure you find all the applicable forces that have components directed toward the center of the circle of motion.